Hello YouTube, thought I'd do a quick video here. This video is going to be about the data pins on my repeater controller board that will work with most mobile radios. This controller board does not use a computer, does not use Vox, no computer or no radio modifications. Like I said, no computer, and it'll let you turn any mobile radio into a repeater. You need two radios. So plug and play. Like I said, no radio modifications. But this video is going to be about the data pins on the controller. What do I mean by data pins? What is that? Now, you don't need to worry about this if you're not going to be tinkering with it, or you don't plan on building a fan controller circuit or whatever. If you just want it to be a repeater, you can disregard this video. But if you're one of the people out there that want to tinker, so to speak, this video will be for you. Now, what we got here is I have a voltmeter hooked up, as you can see on your screen. I have the ground of the voltmeter hooked up to the ground pin on the terminal here. That has to be done to complete the circuit, obviously. And now I'm going to take my probe and we're going to go on the two pins. Now, the first pin is what they call would be an active low. And what that means is when the interface board is keyed up, that pin will go to 0 volts, or what they say, active low. Now, the meter is not going to show a perfect 0. It's going to show some millivolts, but basically that means 0 volts. So let me show you what I mean. That's going to be this pin. When it's in standby mode, there is voltage on there. That's what it's supposed to do. When I key up a radio off camera, so I don't interfere with my meter, RF is really fun when you try to do this stuff. When I key up and you'll see the radio, this receive radio, actually, I'm going to get my pointer here. You'll see this receive radio here key up. So when I key up this radio, this is going to go down to 0. That's an active low. Matter of fact, you can probably hear the radio, my voice come over the radio. So that's what that pin is. Sometimes you need that for some circuitry. The other pin is the opposite. It goes to active high, or a logic high, when this board is keyed up. Let me go to that pin. Normally it sits at 0 volts. Again, the meter will show millivolts because it's just phantom readings of the meter, which is normal behavior. When I key up this interface board, or the repeater, you will see it go to an active high state. Now when I unkey it, it will go back to 0. Those are what we call logic data pins, I guess is one of the terms. But that lets you go ahead and tinker with this. You can build your own little circuit. You'd hook up your wires to the screw terminals accordingly to which one you want. They both work at the same time. So they're not independent. When the board is activated, the one pin is a high, the one pin's a low at the same time. So maybe I'll do some videos on how to hook up a relay so you can hook up a fan. Maybe I'll do something like that. Like I mentioned one time, that you might want a fan to only turn on when the board is active. When the board is active, that means this radio is in transmit mode. And if you want to have a fan blow on it, that would be a good time to do that. You can have that board do that. Now, this data pins on here are low current. They're not going to run a fan. It's not going to run anything that requires a lot of current. Now, you can use a relay to do this. Now, depending on what type of relay you use, you may have to build a little relay driver circuit to run the relay. Relays are good for high current type of circuits. But that just kind of gives you an idea what I'm trying to tell you. I'm tossing out different ideas. So you can use a relay. That's one idea. Many different ways. But the point is, this is a low current digital circuit. For logic, high and low. Now, I know some people are going to see the 9 volts and they're going to say, "Whoa, that's more than 5 volts." That's right. That is correct. Logic high is considered between, I believe, 2.5 volts or 3.5 volts, up to 12 volts. I don't like running it at 12 volts. That's too much of a max. So I go in between and I do the 9 volt thing. That's why you see the 9 volts. But that is obviously considered a logic high. Same with when I'm on the low pin. That's why you see the 9 volts, because again, I like working with the 9 volt. I'm in the middle. It's a good solid logic state. So other than that, so that's how the data pins will work on this board. I don't plan on changing that unless during my testing something comes up and I'm not happy with it. But for the most part, I will be playing with that. And a matter of fact, just for, I don't know if I can do this. Let's just try it once. Let's just kind of show you here what I mean. I don't know if this is going to show up on camera or not. I don't know if you can see that, but that's an example. What I can have it. Turn on this. It's turning on a light when the board is active. So hopefully you can see that. You probably can't. Let me kind of give an example. Maybe this might be a better way of showing what this. So let's say I want to, even though there's LEDs on the board already, but let's say I want to have a light come on for an example. I would hook this up on the logic high pin, and as you can see, I can have an LED light turn on. So that's just kind of an example what this pin is kind of lets you turn on whatever circuit you want to make when this board is active. Oh, probably didn't have a good connection there. There you go. So hopefully that shows up on camera. I'm not making a good connection, but you get the point. So, at any rate, that's what this is kind of for. Like I said, it's really meant for people who want to tinker with it. If you're not that type of person, then you don't have to worry about those pins. You don't need to worry about those pins to make this board work, as you can tell. So there you have it. Any questions or comments, please post them down below. Please subscribe. Thank you and have a good day.